I'm going a bit more technical. This means that I'm going to introduce some of the main concepts that we are using for routing. And I will start by introducing this new service concept that we call hyperlinked entities, which is, it follows very much the microservices architectural patterns. This means that an hyperty is itself very autonomous, so it provides a set of business capabilities with the minimum dependency on other services. And besides that, it has a few unique characteristics, including the association to a user. So this means that at the end, an hyperty performs some tasks on behalf of a user. And the user, the identity of the user is completely decoupled from the provider of the hyperty. So this is really another big difference. So, and gives the power to the user to select the identity to be used. Another very important characteristic, and this is very much following and fulfilling the requirements that Tassos just mentioned, that is an hyperty is inherently interoperable. So this means that the standards that are required in order to make two different hyperties interoperate is minimum. We don't need to standardize protocols or service APIs in order to have two hyperties to talk each other. Just the data format is required to be in common. And for that, we are using, to formalize, describe the data format, JSON schema. It could be something else, but we have decided to use JSON schema. Another very important characteristic is that we have chosen to use JavaScript at this point in time. And so this means that hyperties can run everywhere. So you don't have to install any specific software in your device in order to have hyperties running. Then hyperties have a descriptor. So this is used in order to know what are the capabilities of hyperties. And basically, we use this to define what are the data schemas supported by hyperties. So what are the data formats that hyperties can handle? And also the type of resources. And by resources, we mean things like voice, chat, file sharing, whatever. Then the way how hyperties communicate to each other is through data synchronization streams. And for that, we are using a very specific communication pattern that we call reporter-observer. And this means that we basically have two types of hyperties. So we have one that we call the reporter. That is the one that has, the only one that has permissions to write on a stream, synchronization streams. And then we have the observers that are the ones that, if they are authorized, they can have access and receive the streams of the changes that are performed on the data object. Hyperties are identified with a virtual address. We are compliant with the URL scheme. So you can see like this one here. So we use a customized URL scheme called hyperty. And then each object it's identified with an URL. Depending on the type of the object, you will have a customized scheme for the URL. So in this case, it's a hello world example. So we have a hello scheme. Then for the project, for the different use cases that we have identified, we have standardized a few schemas. For example, for WebRTC use cases, we have defined a connection data object. And the connection data object, basically, it's compliant with the WebRTC standards. So we have defined, we're just taking what the API specification is using. And for each direction, we have a connection data object. So in this case, the connection between A to B has a data object connection, and from B to A, another connection data object. So this is used in order to support bidirectional communication between two hyperties. And as you can also see in this case, the connection itself is also identified with an URL. That in this case use the scheme, the URL scheme connection. Then we also have use cases for Internet of Things and machine to machine. And for that, we have a context hyperty with a context data object. We are also following IETF draft for the definition of the data schema that is used for the communication between hyperties. Just to give you an idea about how it works, I will try to have a short demo that is supported by some of our test beds in the project. So let's see if it works. So I'm gonna load the runtime where hyperties are executed. So on the left, I'm using a domain, iBroker domain. It's based on our test bed. On the right, we have another domain that in this case is from Deutsche Telekom. I'm also loading the runtime. And now I can select the hyperty to load. In this case, I'm going to load two different hyperties. So I will pick, so you can find here a few ones that we have developed. And I will use, in this case, a connector hyperty that we have developed to support WebRTC. At this point, I'm going to select the identity that I want to use with this hyperty. So I am the one, the user, that is going to select the identity. It's not the service provider. So I have the option to select the IDP. In this case, it's Google. And I'm going to select my own Google identity. So the hyperty now is loaded, running in this browser. You can see the data about my identity that is associated to this hyperty. And now I'm going to do the same on the right. But now I'm going to select a second different hyperty developed by Deutsche Telekom. And it will also, in this case, it will automatically select the identity that is on the Anonymous tab. This case is from Resync. Let me just extend a bit more. Yeah. So it's like a fake identity from Resync project. And as you can see, it's really a completely different hyperty. At this point, there is no knowledge between these two domains. So this means that from the iBroker domain has no knowledge about the T-Labs domain. And as you know, in WebRTC, there are no signaling protocols standardized. And these two domains have not standardized any common protocol for that. So now, let's imagine that I want to talk with this fake user. I'm gonna put here his address. So in this case, it's an email address. I could use something else, but that's what we have now. At this point, I have still to set the domain where it is, but we are working in the global discovery where it won't be needed in very soon. So it's from T-Labs domain. I'm gonna search, so if everything works okay, it will retrieve the hyperty that is associated to this user. It's telling me that this is the address of the discovered hyperty. Let's check. So it's the same address as you can see here. and also the capabilities of this. So it supports audio video connection. Okay, that's what I want. Then I can try to call this user. So let's see if it works. So an incoming call is coming in with the identity associated to the user. I can see, okay, I trust this guy, I'm gonna accept. And then here you go. So we have established WebRTC call between two different domains and with different implementations of Hyperties, and there were no standard protocols or APIs for that, just the data format. So this proves that it's possible to have interoperable services just without having to standardize protocols or APIs. Let's disconnect and resume my presentation. How long should I have? 4 minutes. I have to hurry up. Okay, so now going to the very fast just to show what is behind. So how do we support this? This is almost like magic, right? So what we have here is really a decentralized service framework where we have some this kind of model, a messaging framework with few virtual routers that are used to route the messages among the different Hyperties. We follow a resource-oriented messaging model. So this means that we have some basic operations that are performed on each resource. So we have create, update, delete, read, CRUD operations, and edit, subscribe, and unsubscribe to support PubSub. And then we have applied this into our system. So in this case, 3 levels. We have the sandbox level where Hyperties are executed for security reasons. And this allows to have Hyperties from different domains loaded in the same runtime, securely executed. And then we have at the runtime level, have the message bus that routes message through different sandboxes. And a third layer, which is at the domain level layer. So this means that it's where messages are routed through different runtimes at the same level domain. Another important concept that we use in order to achieve this is the protocol on the fly. So this means that the protocol that is used to interoperate between different domains is selected and loaded during runtime, not design time. So that's how we don't need to standardize protocols. Depending on the domain, I have a well-known URI where to download the protocol stack, and that's the one that is going to be loaded and executed in the runtime. And then we can programmatically set up the data synchronization streams between the Hyperties. So in this case, I can set up a synchronization stream between this Hypertie, that is the reporter, and the different observers that can be run remotely in different runtimes or locally in the same runtime. And finally, we also support end-to-end encryption, and in a decentralized way. So we use IDPs that can be selected by the users that are used to generate tokens that are exchanged between the different endpoints and used to encrypt the streams between the different Hyperties. Jean-Michel will explain a bit better how it works, but that's the idea. So at the end, this is the big picture. So we have a catalog from where you can download Hyperties, protocol stubs into the runtime. As soon as the Hyperties are instantiated, they are registered at the backend from where they can be discovered. And then we can also have global discovery. So also Jean-Michel will explain a bit more about this, but in this way you can also globally discover Hyperties independently where they are. And the demo that I'd show you actually it's something like this. So we have two different domains, the iSmart, the T-Labs domain. There are no network-to-network interfaces between these two different domains. What we have is that the protocol stubs are loaded into each runtime, and then messages are exchanged between only one domain. And so we're not using network-to-network interfaces. And I think that's it. So I think I managed to to do it in time. So we also have here a more concrete repository where you can start and have a look. You can start there to look for the different repositories. We have a few of them, and start having, so you can just play around trying to develop some Hyperties and applications that we support with the toolkit. Thank you. Now questions with this. Hello? Yes. Yes.
The question is very simple. Can we use this for intercommunication between, for example, Viber and Skype, or between Viber and a public switch network, or mobile network? That's the
Okay. Thank you, Zenet. Yes, we should. So that's actually something that we are working for phase 2. So we are just finalizing. Actually, we have already finalized phase 1. And so we are supposed in a couple of weeks, months, to have interoperability with IMS, also with other types of legacy domains, that's what we call, including Slack, so like over-the-top domains. So this means that we want also to demonstrate that we are not another island. So we want to be also fully interoperable with other domains that are not fully compliant with resync. More questions? No? Okay. One more?
I would like to know how is the learning curve to enter into all of this? 1 month, 1 year? What do you think?
Hopefully, not much. But actually, that's something that we want to have feedback. So we really invite you to have a look on the GitHub. So we are trying very hard to have it very developer friendly. So that's from the very beginning we design APIs, and actually also having some tools really to facilitate the developer. So in principle, the developer doesn't have to know all this stuff. So just a few APIs are required from the developer perspective. So the backend should be really behind the scenes.
Possible to use some backend that already exists, and I just call the APIs and have some service working, right?
Yes, actually, by default, the toolkit that you can install for the development uses by default one of the testbeds that we have. So we don't have to set up like the full environment in your PC. I think we still have time for more one question.
I would like to add to this answer about the learning curve. This is something that we try to find out as we speak. We have put some developers on the framework and basically ask them, just use it, just do whatever you want, just tell us what is your experience and when you feel comfortable to actually develop something. Along that goes also improvement of documentation and what we call also packaging, so that all things that are needed, for example, from a application developer or for a Hyperties developer are really consistent in one place. And so we don't have a concrete answer right now. It's something that we will have in a couple of weeks, perhaps. But I admit when I tried to look into that, I was a bit overwhelmed.
Okay, thank you, Tassos.